you have to go to test submission. Then you have to enter your email ID, some email ID. Okay, then go to next. Okay, for me, I am getting this thing on my phone. So but it will be a problem if you don't have a Gmail ID, it will be a problem. Yeah, so now here you have test submission. So put your name, put your school name, put your grade, put your subject, and add file. Then you will have to select files from your device. So you can take a photo. So you can take a photo. So here I have taken photo. And it has added it. I can go for add more files. Take photo. Okay. Then I have taken another photo. Here I have taken another photo. Then use photo. So like this, I want you to do it. Then you just upload. Now this process will take little time. Now you see this file size is very high, 194, 1.94 MB, 1.86 MB. That is very high. Now if you want to lessen it, take it on your phone and then try to send it as a WhatsApp. So when you send it as a WhatsApp, WhatsApp reduces the file size. Then from your WhatsApp, you email it to yourself. And once you email it, then you download it into your system. And then you try to work on it, it will work out faster. Okay. I repeat, if you look at this, this is 1.94 MB, this is 1.86 MB. But the same image, the file size will come to kilobytes if you send it as a WhatsApp. So try to take it out as a WhatsApp and then work with a WhatsApp. If you work with a WhatsApp, WhatsApp will so take photos, put it on your WhatsApp. Then from that WhatsApp, you send it to yourself as an email, download it onto your system, and then take from the system. Then it will work out very effectively. It won't be such big files. Okay. So I'll then you just submit it. Now I will close this. I'll teach you again. Go to seekerseducation.com. In seekerseducation.com, you go to test submission. Okay. Once you get test submission, you will have to, there will be one email, Gmail, you will have to enter Gmail. Then you will have to enter your name, the school name, your grade, subject, and then add files. Okay. Then you can select file. In my case, I'll just go to photo library. Then I'll explain to you. I can take this one. Done. Now you see this is also in MB. But I will show you one more photo which I've got from a WhatsApp where the file size will be less. Okay, no, I won't be able to get it here because all are like that. Let's see how much this one is. Yeah, so I have not done it here, but then once you take those photos, get it to WhatsApp and then download it, then things will be faster. Okay, so let me check if there are any questions that you all have. Sir, the website, KNMS students should go to Edu Advaita and submit it there. All other students come to this website. Sir told to upload in PDF format. Very good. Very good. No problem. PDF format is very good. Yes, yes, yes. You upload the way Amit sir told you. It is not required. PDF alone is not required. PDF means it is easy. PDF means it will get compressed automatically. It will get compressed. Very good. So you guys are too smart. I am confident you will be able to do it. Yes, yes. KNMS students should submit in Edu Advaita. Yes. How to upload? Hey, they have called you 2, 3, 4 times and they have done meetings. So I don't know how to upload there. Pattern of the exam paper. I already discussed. Again, I will discuss. Okay, 5 minutes. I will discuss paper. I will discuss. Okay. Yeah. Yes, sir. Huh. So call up Ramesh, sir. Huh. Okay. Maximum how many pages you write to your heart's content? Where can we find the question paper? Question paper you will get in your Learnity portal. Sir, aren't we having any surveillance while writing tests? No, your parents are being called up and they are being asked to do the surveillance. I will ask you to open Zoom and then sit. We can upload in when and if we have such an assignment to submit. Yes, 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 we can. Yes, you can submit PDF, you can submit photo. No, you don't have to submit it here. If you are submitting it there, it's enough. Amit sir told to write, okay, you write, but I am telling you, you write to your heart's content. If you put 21 pages, it doesn't mean that I won't take it. Okay, so I'll take it. Don't worry. You write to your heart's content. You don't need 20 pages. You need 5 pages. If you write 5 pages, it is enough. Questions are from NCRT, sir. Yes, sir. Can you extend the time of submission? No, 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 no. Half an hour is enough to submit. Website. Yes, you will have. You will have. If you have any difficulty anywhere else, you please come to our site and then submit it. I have no problem. Yes, yes, yes. Only files with 20 pages. Don't worry. You won't need more than 5, 10. If you write correctly, if you write properly, 6 pages is more than enough. Okay, so will we have one more doubt clarification session? No, enough of physics doubts. Now you have maths doubts. You solve your maths doubts and then sir will guide you. Don't worry about this scam scanner and all those things. You just upload, you take photo, convert to PDF and then you put it. Question B, 10 minutes of exam. So to read it, generally they give you the paper and 3 hours. I'm giving you the paper and 15 minutes. No, 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 you won't have any reading time. Okay, so this is all the story that I have from my side. Let us get back to work. Please don't bother about the test. I am not going to give any gold medals at the end of it. Okay, so just read to your best ability and then answer the test paper to the best of your ability. That is more than enough. pattern of the paper. Question 1, 1 mark question 20. 10 MCQs, 5 fill-ups and 5 short answer type questions. Okay, then you will have 7 2 mark questions. No choice. No choice. 3. You will have 7 3 mark questions. I have totally given 8 questions. I am expecting you to write 7. So there is one choice. Then I have given you, then you have to write 3 5 mark questions. I have given 4 questions. I am expecting you to write 3 out of them. So there is again one choice. Okay. Now, properties of charges, very important. Properties of field lines, very important. Electric field, very, very important. Gauss law, super important. Principle of superposition, very important. Dipole, very, very, very important. Okay. Then all applications of Gauss law, very, very important. Book back questions, very important. This is for chapter 1. Any doubts you have? Okay, so I hope there are no doubts on chapter 1. Okay, now chapter 2. Electric potential definition, very important. Then electric potential energy. Then electric potential at any point due to a dipole. Okay, then dipole in an external field. Then potential and electric field inside sphere, outside sphere. Potential inside sphere, outside sphere. Then electric field inside sphere, outside sphere. Different types of sphere, conducting sphere, non-conducting sphere. Then all book back questions are very important. I am not writing anything. Only the chat box is visible because I am sharing only the chat box. I am basically telling you everything that is there in the text. I am not telling you, I am not leaving anything. I am telling you from top to bottom. I am telling you everything that is there in the textbook. Okay, so I am not giving any specific information. I am only giving what all is there in the textbook I am giving. Okay, then capacitor. All derivations in capacitors. Then circuits of capacitors. Then dielectric. Okay, so you read your textbook, then you do your best. That is all that is expected. Nothing more can be done, and don't get worried about anything else. Okay, so this is all that I have to share. I don't have anything else to share. Let's go back to our work. Our work is to learn more about current electricity. We were looking at electric circuits. And then we first read series and parallel circuits. Okay, we have read series and parallel circuits. Then I explained to you where we can apply series parallel, and then we did a couple of questions. Then we moved on, and then we did something called as the Wheatstone bridge circuit. Now, when we did the Wheatstone bridge circuit, I told you a point that if there are 2 points with the same potential, a wire between them will not have any current. Why will it not have any current? Because current moves only from high potential to low potential. Current moves only from high potential to low potential. Okay, only if there is a potential difference, current will flow, otherwise there will be no current, right? So we removed wire, we can add wire. Yeah, so this is a trick 1, this is trick 2, and we saw a few questions based on that. So let me move ahead and let me work out one more question with you. So I have a resistor of this kind. Okay, now suppose this point here is A, this point here is B. Can you find out what is the effective resistance? This is R, 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 and this is R. Question, what is the effective resistance? Okay, what is the effective resistance? So you can work it out quite simply. These two are in series, these two are in parallel, these two are in series, these two are in parallel, and these two are in series again. So 2 series is 2R, 2R and R will give you 2R by 3. So 2R by 3 plus 2R by 3 will make it 4R by 3. So the effective resistance of this is 4R by 3. I hope you are able to understand. This R and R are 2R. So 2R into R by 2R plus R. So that will give you 2R by 3. So 2R by 3 is the effective resistance of this and this. Now these two are in series. So 2R by 3 and 2R by 3 will give you 4R by 3. So 4R by 3 is the effective resistance of this circuit. Okay, so very simple, right? Now I have another small question for you. This is a resistor, this is the same resistor, same thing. Now here I have connected one. So now I have A here, B here. Now what is the effective resistance? What is the effective resistance of this system of resistors? Okay, so how do you go ahead with it? So the way you go ahead with it is this. Suppose I Okay, first understand that this cannot be done by series parallel. If you come here, because of this you can't do anything, because of this you can't do anything. So this is not series parallel. Now nor is this Wheatstone bridge. It's not Wheatstone bridge, because in Wheatstone bridge the output is taken here and here, but here you see there is a wire going here, there are wires, so there, this is not a Wheatstone bridge also. Okay, so now how do you do it? So now just imagine there is a straight line here. I'm cutting it. Do you see that the left side is the mirror image of right side, or the right side is the mirror image of left side? This line that I have drawn, I'll call it the line of symmetry. So this is R, 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 this is R. So I have a line of symmetry, and I'm making a statement that all points on the line of symmetry are at the same potential, are at the same potential. Okay, this is not required for NCERT. Okay, this is not required. Up to Wheatstone bridge, if you read, it is enough. எனக்கு தெரியும், so I am telling. தேவையில்லை. Okay, புரியலனா don't worry about it. இந்த question எப்பவுமே உங்கள் எக்ஸாம்ல வராது, திருப்பி கேட்க தேவையில்லை. So all points on the line of symmetry are at the same potential. புரியுதா? So if they are at the same potential, a wire could be joined to between them. Okay, a wire could be joined between them. So now what I am doing is this is broken into two parts, R by 2, R by 2, and this part is joined here. So this part is joined here. Now I will redraw the circuit, and I am saying that the circuit looks like this. Okay, now because I cut it into two parts, this is R by 2, R by 2. This is R, 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 R. Now if you look at these points A and B, you will see something. Now I'm seeing that these two are in parallel. This is in series, parallel, series. Yes, can you find out what the effective thing is? Before asking me a doubt saying I don't understand, first you think what I am saying. Okay, you think what I am saying, then don't tell me I don't understand. Tell me my problem is here. Okay, so please understand this and then try to work it out. Okay, so the important point to understand is that points on that line of symmetry are at the same potential. Now because they are at the same potential, any wire between them can be added or removed without any problem. In this case, now I am adding a wire, because if there are 2 points at the same potential and if I am adding the wire, then there is no current in it, so it doesn't matter. Okay. So R by 2 and R in parallel. So R by 2 and R in parallel will give you R into R by 2 by 3R by 2. 2 cancel, R cancel, it will become R by 3. R by 3 and R in series will make it 4R by 3. 4R by 3 and R is into R by R plus 4R by 3 will make it 4R by 7. So 4R by 7 on this side, 4R by 7 on this side will make it 8R by 7. So 8R by 7 is the correct method of doing this. Okay, so 8R by 7 is the correct method of doing this. A Wheatstone bridge is not a direct consequence of the rule of line of symmetry. In fact, the rule of line of symmetry is a consequence of the concept that we are learning in Wheatstone bridge. The fundamental thing, I hate to call it the line of symmetry, but I don't want to sound ignorant. So I use this line of symmetry, but we are identifying points which are at the same potential and we are trying to connect them. This line of symmetry is a nonsense concept. It is not a true concept. Okay. The true concept is to identify points which are at the same potential. Okay. So I would not want to use this because as a physicist, my job is to work with theory, not to work with statements. So this gives me a statement. It's easy, people like it, students like it, but I don't want to sound ignorant. So I also am using it, but I would not like to use this. I would like to find this points at the same potential, identify points at the same potential. Once you identify points at the same potential, then you can do whatever you want to do. Because line of symmetry doesn't work. It doesn't work at all places. You have to be very careful when you apply line of symmetry. Here is a cube. Now here also you will have line of symmetry. Okay, here also you will have line of symmetry, but here you can't apply it. So we have to be very, very thoughtful. Okay. So don't, I mean, yeah. So I would like to say always points at the same potential. So that is what is the appropriate thing. Okay. Can we have a horizontal or diagonal line of symmetry? You can have. See, that's what again I am saying. There is nothing called as a line of symmetry. Okay, there are points which are at the same potential. So they may be along they may be along diagonals, they may be along sides, they may be anywhere. So you have to look at a diagram and then you have to identify points which are at the same potential. So we have to look at that. In case of a cube, how do we point? We have to find out, we will see, we have not reached there. Once we reach there, first you do what we are doing right now, we will reach there slowly. We can't rush. Okay, so once this is understood, then here is another question for you. All resistors are R. Find the effective resistance. All resistance are R. find the effective combination. This question also will never come in your board. Okay, it will never come in your board exam. This question also I have told you already. So here also I have a so-called line of symmetry. So what I did on one side earlier, now I do it on both the sides. Everything else is the same. Okay, so quickly find out what the effective resistance is. All of you, please try. Make an effort, don't get it, then you see. But without trying, it won't work out. Okay, so try to work out R by 2 and R are in parallel. So it will become R by 2 into R divided by R by 2 plus R. So how much is this? This is 3R by 2. This is R by 2. So it will become R by 3. Now R by 3 and R by 3 and R will make it 4R by 3. So now I can draw effective circuit like this. So this is 4R by 3. This is R. This is 4R by 3. This is 4R by 3. R 4R by 3. Because same thing you will do on this side also, right? So if I want to find this out, it will become 3 by 4R plus 3 by 4R plus 1 by R. So the effective is 4R. So it looks like 10R by 4, 10. So it will become R effective here will be 4R by 10, which is equal to 2R by 5. So this side is 2R by 5, that side is 2R by 5, the net will become 4R by 5. So the effective resistance is 4R by 5. Okay. Now when you go for your VIT exam, when you go for Amrita exam, they will be giving you straightforward questions like this. This is a standard question, there is no variation. So it may help you remember this answer so that there you can go and click on it quickly without really working it out. Okay, so the only reason why I'm doing it, this question will not come even JEE mains, this question will not come. But I have seen these questions in the Amrita exam and the VIT exam. So if you go for it in that, from that point of view, it will help you. Okay. I have set the paper for the physics NCERT based exam. I have no other book other than the NCERT textbook. Okay, that's the only book that I have with me. So there is no other reference book from where you, first thing is you cannot copy any question from anywhere. All the questions which are there are new questions, in the sense the numbers are my own, everything is my own. So don't read any book, it won't help. Okay, so just work out the questions on your own. Whatever you know, it will help you. Okay, so I hope you have been able to understand this, right? Next, I am forced to look at a question which is there in the NCERT textbook. So I'm going to answer this question. So there is a cube like this. This is there in the solved example in the NCERT textbook. So I am trying to look at that and then I am trying to answer. So the question is like this: 12 resistors form a network as shown. What is the effective resistance along the leading diagonal? What is the effective resistance along the leading diagonal? Okay, they are all equal resistors. Okay, so I will do this in multiple ways. Please focus. First thing is, suppose the current going out here is I. The current coming here is also I. Now, when the current reaches this junction, the current has three ways. The current can go this way, the current can go this way, and the current can go this way. I am telling that all three ways are the same. Why? Because two resistors I'll go to the other end, two resistors I'll go to the other end, two resistors I'll go to the other end. So I am saying that all these three routes are the same. So if all these three routes are the same, the water will go by 3, by 3, and by 3. Do you understand this? Now the current comes here. Now after coming here, the current has two paths. It can go like this, it can go like this. And if you see, both the paths are the same, because after one resistor, both will connect you to the same point. So it will again divide and it will become I by 6 and I by 6. Okay, so the current here is I by 6. So this is I by 3. So this will also divide I by 6, I by 6. Now this will also divide I by 6, I by 6. Now from here I by 6 is going, from here I by 6 is going. So this will become I by 3. Now here what is going to happen is, from here I by 6 is coming, from here I by 6 is coming. So this will become I by 3. This is also going to become I by 3. Now I have a closed loop here. So in this loop, I'll say V is equal to I into R effective is equal to I by 3R plus I by 6R plus I by 3R. So the net will become 6 here, 2 plus 2, 5R by 6. So R effective is equal to 5R by 6. Okay, this is more as a technique to solve than anything. This question came in the Amrita paper. As it is, students who were able to remember 5R by 6 got the score. Okay, so this is one method of working it out. Please make notes and then we will move on. Will the test be easy? Yes, the test will be very easy. If you read your notes, test will be easy. Problem will happen only if you don't read your notes or the textbook. No, it is not 5R by 6 only for one side. It is whatever, it is between this from here to here, between this from here to here, whatever R effective, only I current is going, I current is going, I current is coming. So I into R effective is equal to whatever happens. So what is happening is, this is equal to I into 5R by 6. So what is 5R by 6? 5R by 6 must be equal to R effective. It is not only for one path. No. For one path, if you go from here, 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 R, it looks something else. Okay, so this is the total. Suppose I close this cube. So if I close the cube, what is the current entering? I. What is the current leaving? I. So what can you say? V is equal to I into R. Now I am saying that V is equal to I into 5R by 6. What will you say? That R effective must be this, because these two are the same. Okay, so this is one way of thinking about how to do this question. I don't know other methods, but I will still try and see if there is anything else that I can do for this. These questions you cannot do it on your own. Okay, I am not expecting that you will do it. I am expecting that you will learn from it. Okay, now somebody asked me, okay, how do you look at points which are at the same potential? So let me see if there is any way I can identify points which are at the same potential. Now let me look at this point. So before that, let me name it, so that if I name it, it will be easy for me. A, B, C, D, E, F, G and H. Okay. Now look at E and look at G. Do you see that they both will be at the same potential? Why? Because there are two potentials on this side. I mean, two resistors on this side and one resistor on this side. So I am going to say that E and G are at same potential. Similarly, now the reverse of it, B and D will also be at the same potential. Yeah, B and D will also be at the same potential. Why? Because they are one resistor from this side and they are two resistors on this side. So B and D. So I can connect them. Without resistance, I can connect them. So now what I'm going to do is I'm flattening the cube. I'm flattening the cube and bringing point E and G next to each other and D and B next to each other, and I want to see what happens. So I have a wire from A to B, I have a wire from A to D, I have a wire from H to E, H to G and H to G. On this side I have F. So I have this wire, I have this wire, I have this wire, I have this wire. So 1, 2, 3, 4, 5, 6, 7, 8. Now there are two wires here, 9, 10. Now there is one wire here and one wire here. So I have point A here, I have point H here, I have F here, I have point C here, B, D, E, F, E, G are there. Now this is where my battery is. Now do you see this will become R by 2? This will become R by 2. This will become R by 2. This will become R by 2. Yeah. Now, oh, so this is not here. Battery, I mean, the connection is not here. The connection is at F. So I have to bring it F. So now this won't be. So this will be R by 2. So you understand this. Now I can redraw this circuit. I'll combine these two. That is 3R by 2. So I have 3R by 2. Then I have this R by 2. Then I have this R by 2. So 3R by 2, R by 2. Then I have this R by 2. Then I have this R by 2. And this 3R by 2. This will be R by 2. And my connection goes this way. This looks like a Wheatstone bridge, but it is not a Wheatstone bridge, because had this 3R by 2 been on that side, then it would have been a Wheatstone bridge. Okay, so now the way it is not a Wheatstone bridge. So we can solve it, but it will take us a long time to solve. From the techniques that we know so far, we cannot solve this. Okay, How to solve this, we'll come to later. Here I want you to teach that, look, there are points of symmetry. I mean, I can't call them points of symmetry because now this and this and this and this are not at the same potential. So G and E are at the same potential, but G and D are not at the same potential. Okay, so how do I know G and D are not at the same potential? So G is 2 resistors from positive, while D is only 1 resistor from positive. So they won't be at the same potential. Okay. So if you can think about it and if you can make notes, let me go to the chat and find out. Yeah, please study the notes. Okay, please study the notes, keeping the NCERT textbook in front of you. So Biksha, I didn't understand your question. Why 5R by 6? I didn't understand that. I mean, I didn't understand. So I'm saying that if I into R is something, see, I explained to you that so here I am explaining to you, I hope you are able to understand that V is equal to I into R effective. This I hope you are able to understand. Then I have gone a closed loop here. In a closed loop, I have applied Kirchhoff's law and I am seeing that V is equal to I into 5R by 6. So I am now telling you 3 into something is equal to 3 into 6. So what is that something? It has to be 6. So I into R effective is equal to I into 5R by 6. So what is R effective equal to? Okay, so that is the logic that we are using. Okay, okay, then yeah, so I think I will stop here. What I will do is I will tell you a few things all over again. Please make sure that all of you are able to listen and get it. So point number 1 for your exam, point number 1, read your notes. Then read only portions there in textbook. 3, every question where possible, draw diagram. Every question where diagram is asked, draw diagram in pencil. 4, 5, one small advice. Nothing is better than nonsense. That means that if you don't know an answer, don't try it. Don't try to guess something out of the way. This is not an advice that I would like to give for the board exam. Board exam, if you write something, they'll give you marks, but I won't give you marks if you write something. I am going to read all your papers, all 300, 400, 500 papers, whoever is writing. I am going to read all the papers. I won't give marks for just for writing something. I won't give marks. Okay. For every question, I will share what my answer is. So within 1 day of the test is over, I will share what my answer is. If you have written that, you get your marks, and how many percentage of that you have written, you get that much percentage of the marks. Okay. So that I am making it very, very clear. So I will share the answer key with you. After you check you have the paper with you, you have the answer key with you. So you can check, and then you yourself can tell me how much you will get. Okay, if your marks match with my marks, or if your marks are less than my marks, I will give you 2 marks extra. Okay, so this is what is my instruction to you. The paper will come to you at 9 o'clock. Where will you get the paper? You will have to go to stg.learnit.com, and from there, against your ID, you will have to download the paper. Paper is 70 marks. In physics, maths is 80 marks. Okay, then you sit down for 3 hours, and then you write. I can ask you to open your Zoom with video and keep, but I don't want to do. I trust you. I am not giving any gold medal. I am not giving any university rank. I am not going to give you any cash prize award also. So it is all for yourself. Why are we writing this test? We are writing this test, one, to understand what is expected from us. Right now, you all have doubts. What should I read? How should I read? And so on. So after this test, that doubt will get clarified. Okay, that is the first expectation. Second expectation, I am not able to see your faces, nor am I able to see your notebooks. So I want to know how much of it you have really learned. Okay, so please try to put in genuine effort, and then you see. There is no point getting nervous about it. There is no point jumping around saying that how the hell can he test me on 2 chapters and all that stuff. I can test. Even now, after putting 70 marks paper also, I'm realizing I'm still not able to give questions on so many other concepts which I can give questions. Okay, so I'm thinking I'll tell you that, okay, next week also we'll write a re-exam on this, and then we will have another paper made on this. So you can make 200, 300, 500 marks papers you can make. In your board exam, you will get 16 marks questions from whatever we have done so far. So if you write a 70 marks paper, it will only be for your good. So this is the way we will be going ahead. Then after you finish writing the paper, you have to go to seekerseducation.com and upload the paper. Upload the paper. There is a heading called test submission. I showed you there is a heading called test submission. So go to the test submission. So there is a heading there called test submission. Go to that test submission. It will take you, you'll have to enter a Google Gmail ID. It will give you a form, a Google form, wherein you'll have to write your name, school name, everything. And then here, test submission. Here, please look. When you open, you get this. When you get this, you click on test submission. Yeah. So now there's a Google form. Please fill up this Google form and then add file. Now you can convert it into a PDF, and then you can put it. Select files from your device. Now wherever you have, you can put your file, and then you can get it from there. Okay. So this is how it can be done. After that, don't forget to click on upload. After it uploads, don't forget to click on submit. Now to do this work, you have half an hour. So I'm expecting that you will start the test at 9:15. 9 o'clock, you will download the paper. 9:15, you will start the test. 12:15, you will complete the test. 12:15 to 12:45, you will upload the test. Okay. Yeah, the board is for 70 marks. Where will it be there in the home page or what? You'll be getting marks and stuff. Yeah, you will be getting marks and stuff. Have we missed anything from NCERT? I don't know. You tell me if we have missed anything from NCERT. You please tell. Derivatives. Derivation of formulas doesn't come in NCERT. Derivations can come in NCERT purely as application. So all applications of Gauss law, those derivations are important. But derive E is equal to minus dV by dr will never come in your board exam. Similarly, derive capacitance C is equal to Q by V will never come in your exam. Derive that Coulomb's law is 1 by 4 pi epsilon naught Q1 Q2 by R squared will never come in your exam. Okay, so you have in your exam only application oriented derivations. So derive the expression for dipole for the electric potential at any point due to a dipole can come in your board exam. So that is what it is. Yeah, board exam is for 70 marks. Okay, so the paper is very, very easy. Just read your textbook. It is more than enough. You don't have to do anything more than that. And most importantly, you have to write. Okay. Which one came last year? Yeah, dipole derivation here. So dipole derivation is a very important question. How much mark from each chapter? No. Actually, in your board exam, from chapter 1, mostly question will be from Gauss law. Okay. Now, all the other chapters, around 5 marks will be from first chapter, 11 marks will be from second chapter. But there is no rule like that. So even for me now, there is no rule like that. I've tried to balance between both the chapters, but I've not figured out so many marks from here, so many marks from here. Okay, so that I have not fixed that up. I've just given you the questions, important questions, and some questions which I think we have spent so much time on. So don't worry about it. You guys are like, I don't know, you behaving as if this is one university exam, and then if you get 10 marks less, you will miss out on your college. Okay, so nothing of that kind is going to happen. Yeah, so just go with a positive mind. Write whatever you know. Don't think of looking at notebooks and all and writing. Your friends may be doing it, but you please don't do. Okay, just write what comes to your mind. You write. I want to check whether how much my students have scored. I've spoken to them now for almost a month and a half. How much they have scored. That's all that I want to know. How much they have understood. That's all they. That's what I want to know. It's more of a test for me than for you. Okay. So yeah, we'll read this again. There are 2-3 more methods. I will do 2-3 more methods later, so don't worry about it. Yeah, focus on your exam. We will do this cube question. There are six more questions I will do with cube, so don't worry. Okay, so that's enough for today. Best wishes to you all. Work hard.